Hello everyone. How are you?
Fine, thank you. How are you?
Good.
How
I'm
are you?
fine. So I share my screen. Only 7 students. So we will quickly go through all the. So today we are going to start. Can you see me? I don't.
Yes, miss.
Yes, Miss, we see you.
What is this? Do you have idea about Fourier transform? Yes, this is the frequency domain analysis of time domain signal. Frequency domain analysis. Frequency domain. Right? You all know. Okay?
Okay.
Then, so in time domain function, it's represented by t, and in frequency domain, it's represented by omega, right? When you take Fourier transform of a time domain signal, you get x of omega frequency domain signal. And it can be written, x of omega can be written as the Fourier of the time domain signal. Okay? X of omega is the Fourier of the time domain signal. Okay? Then MATLAB has, you know that what is the frequency Fourier transform formula for any signal? It's summation from minus infinity to infinity. X of t e raised to the power minus j 2 by f n. So this is the formula, right? Here in MATLAB, you don't have to do all this calculation. You just have to write this command Fourier. It will give you the Fourier transform. Then inverse Fourier transform. This is coming back to time domain signal from frequency domain. So in MATLAB, just write this command I Fourier. This will give you the inverse Fourier transform. Then before executing Fourier transform commands, these time t variable and omega, it should be declared as symbolic variables. What is symbolic variables? Symbolic. What are the symbolic variables? For example, you have in MATLAB a is equals to 2, b is equals to 3, and you write c is equals to a plus b, right? But the MATLAB will give you the answer. What will be the answer? Anyone?
5.
Yes, MATLAB will give you 5. Now I want MATLAB to give me answer. I don't declare them. I just write c is equal to a plus b. I just write like this. What MATLAB will do? It will give me error. It will say undefined variable a, undefined variable b. Yes? So if I declare s, y, m, s, a, b, then if I write this command, MATLAB will give me answer a plus b. It means if I want variables in my answer, then I should declare them as symbolic variables. Okay? So do you understand? Do you
Yes.
understand?
Yes. Okay.
We must
So-
clarify the symbols first, or the
Yes.
variables.
Declare, or because in Fourier transform we get the answer is in terms of a equation. So equation have the variables. So we should define those variables here so that MATLAB doesn't give us error. Okay? So we will declare by using sims command. So let's say a cosine of omega t, not of t. How many variables are there? 1, 2, 3. There are 3 variables. First step is to define the variables. A, not bracket, there is no bracket, and there is also no comma. A omega naught t, right? Then write the function f is equals to a multiplied by cosine of omega naught multiplied by t, and then Fourier, Fourier of f, this function with omega naught, because this is the frequency. Whenever you find the Fourier, then you have to write this omega naught. Whenever, so you have 341.
Same face.
Really?
Same. فكر أنت بديع.
I am Medina.
يعني sit down here.
Do you have 341 now?
Yeah.
Here 341.
Yeah.
So who is staying with me? Hala?
No hard.
Hala is, I don't know. Okay. So omega, that is frequency. Whenever you find the Fourier transform, you have to declare as omega naught here. If you find inverse Fourier, then you will write your function with t always. These two things should be always here. For Fourier, omega naught. For inverse Fourier, t. Okay. So I remove this. Okay, now try to write this function here. No, you don't have to write this, just write. And then here omega naught. Can you try this and then tell me if you get the answer? What is direct? Direct is delta function. So it was online today.
Online?
Yes. You have it. So please, students, just write this. Anyone?
I am writing now.
Mahmoud, okay. I was expecting something from you.
Miss,
Yes.
Miss, where is the file? I didn't get the file in the model.
It is there. Wait, I show you. If you go to the Moodle,
Okay.
Hmm. If you go to the Moodle 341, come here, lab 3 examples.
Okay.
Download this and start working on it.
Okay, Miss.
Can you just put it on the code, please?
Yes, show me.
No, I want you to put the code. I'm writing.
This one. That way. Yeah, see? Mahmoud, is it done with you?
I'm just writing. 1 minute.
Okay. How about Tana? Tana,
Miss, I'm finished, but
Uh.
the result not the same.
show me. Share your screen. Share your screen.
Okay, I'm sharing.
Yes, this is same. This
Really?
is yes.
Okay.
Pi a into delta of t minus omega plus delta of t plus omega.
Okay.
Delta function. So this is correct. So I move forward now. So now I go forward.
Miss, can I share? I have error.
Okay, share me.
Okay.
Miss, if we just write the code, if we run it, there is a solution.
Yes, there will you will get the Fourier transform
It's
equation.
giving
No,
error.
I have error too.
Tell me what is the error? Zainab?
Okay, I will share now.
Show me Zainab. What is
Miss, I will try to share with my computer, but it's right. Wait for the host to start this meeting. Why?
Miss, can I share to show you?
yes? The
Okay.
meeting is already started.
I know, but in my computer, I don't know why.
Okay, here now. Try now.
Did you see me, Miss?
Yes, Ibtihal. Yes.
Is it
Exactly.
okay?
Yes, yes.
Okay.
Zainab, can you try now?
I try, Miss. I'm wait.
Okay, it's okay, no
Let
problem.
me share it with my
I
camera.
will go to the next. Okay. What kind of error you have? What is the
Can
name?
can I show my results, please?
Yes,
There is no my error. I mean,
you got error.
yes.
What is this?
This is the error.
It's Fourier. Fourier. You wrote Fournier.
FOUR.
Rier. Remove N.
Okay.
Okay. So I move forward now.
Okay.
Miss, can I show you?
Okay. Yes. 1 minute. Yes, Dana. So okay, I move forward now. Yes, Dana, it's correct. Yes, good. So I will move forward now. What happened? Where is the error? Yeah. So now, okay, now you know that how to find the Fourier transform. Now you have to find the Fourier transform for this signal. Okay, this is a triangular signal. Okay, so first of all, define t omega because you need this t and this omega. Okay. Then this is a rectangular pulse. These are the built-in commands, you have to memorize them. So just write rectangular pulse. From where it is going? From -3 to 3. Okay. From here, it starts from here to here, -3 to 3. There is a rectangle, and then Fourier of that rectangle will give you the rectangular pulse. Sorry, the Fourier transform of the rectangular pulse. Okay. Can you do it? I will upload these slides also. You can practice this at home also. So I move quickly forward. Why?
Miss,
Yes.
can you hear me?
Yes.
I share my screen, Miss.
Yes.
See?
Okay. So this is the problem. You have to download this symbolic math toolbox. You have to install it. This will not run well. So maybe during my office hours, if you can come, I can help you. Because you have to install a program, then it will run.
Okay, how will I solve my lab assessment?
انا صارت نفس المشكله زينب لما تسوين داونلود على البرنامج
ايه
سوي تشيك على البوكسز كلهم
اي بوكسس فيهم؟
لما تسوين داونلود على الكمبيوتر
ايه
اول شيء راح يطلع لك بوكسز تحطين تك على كلهم المفروض.
So what is unit step function? You all know this. And in the previous class, I told you that the name of the scientist who developed this unit step function, the name is Heaviside. Okay, he actually developed this function. So how we can write the Fourier for this? Very simple. Just define the unit step function and then these two symbolic variables, and then just write the Fourier. You will get this pi delta of omega minus I by omega. This is the Fourier transform of a unit step function. Okay. So Zainab, please try to install the this toolbox. Then your problem will be solved. I think any student can help you also.
okay.
Okay.
Okay, Miss.
Done. Okay. Now find the Fourier transform of a triangular function. In the previous example, we found the Fourier transform of a rectangular function. Now, can you guess that how I can find the Fourier transform of this triangular function? It starts from 0, goes up to 5, and then the peak amplitude is 5. Can you anyone guess? The first step is symbolic TW. Okay. Then F is equals to triangular pulse. Triangular pulse, very easy. Then the pulse is going from starting from 0, 5, and then peak amplitude is 5. So then Fourier. Just see here. Do you find this Fourier transform easy? Do you think it's easy?
Little confusing.
Why?
That's it.
What? No. You finished?
Yeah.
Really?
So I have at 5. I have hardware at 5.
Oh. I think this.
You finish at 5?
Yes.
Okay, I'm going to be please. Okay.
Please just sit and relax here and listen to my lecture. I can. So, bye. So, is it clear to all of you? Yes?
Miss, do we have to solve the examples or do we have to where?
Now we will solve examples in the class, and then you have to solve your assessment and upload on the Moodle. The assessment will be similar to the examples I am doing here. Okay, I will also upload these slides, and then you can take help from this to solve your assessment. Now I have a function f of t, which is e raised to the power minus t square minus x square. So can anyone tell me how you can write exponential function?
EXP.
So yes, exp. So the first step is
Simple.
yes, and then t
T and X.
x, and then don't forget this also omega.
Oh my God. Okay.
Yes, then f is equal to exp
Minus T
like this
square
minus x,
minus X square.
and then Fourier of
Fourier of
function.
X F with omega.
Yes, exactly. So these three steps. So I don't think there is something confusing in it. Just three steps. First step is defining the symbolic variable, then defining the function, and then just taking this Fourier. Very simple. Yes?
Yes.
So it's written here. It's very fine.
Yeah. Need help?
You're writing word with me. So Fourier of always Fourier, when you find the Fourier, you have to write omega not t. F with omega. With your omega, define omega. Yes. Omega. Yes. So done. So now can anyone tell me that how I can write the Fourier transform? How I can calculate the Fourier transform for this function? Anyone?
Simple.
Yes. And for what?
For omega and J.
Okay, so one more thing. So this is inverse Fourier transform. In the previous, you see now here is omega, here is also omega. In the previous, we were always having x of t is equal to some function, exponential or sine, like this we had. Now we have our equation is in terms of omega. Okay, we have to convert it to time domain. So what we will do? We will take inverse Fourier transform. The steps are same. Then you will define the function. For example, x is equals to 1 divided by 1 plus j is written in MATLAB as I into omega, and then inverse Fourier I Fourier of this x with, now what I will write here. This is inverse Fourier
T.
transform.
T.
T, yes, exactly. So this is also very simple. Now I will see. You don't have to write this T naught. Okay? Do you find it easy?
What's it?
Which one? Go down. No, not so much. It's fine. I will upload these slides. So no worries. So also, all of you, you can also try to solve all these examples. If you have any problem, then you can ask me.
Miss,
Yes.
the last question, I didn't find it.
Which one?
This one.
What you didn't find?
I didn't find it with the examples.
Yeah. I forgot to put it there. But I will upload these slides, you will get it there.
Okay.
Miss, do we have to solve the examples with you now? Because different questions.
It's up to you because these are very simple examples. Before this in lab 2 and lab 1, there were some signals which were very useful, but this is only one command. You don't have, it's up to you if you write or not.
So we will keep it with the slides with you.
Okay, I will anyway upload these slides and try to solve all the examples because in my example file which I uploaded on Moodle, it has a lot of examples. Okay.
So you only need from us only the assessment.
Assessment, yes.
Okay.
So now this, can you tell me how I will find the inverse Fourier transform for this function?
Yes.
Anyone? Tell me.
Samples.
Yes, and then this will be
Omega T.
Yes, and then
And
define the function.
yes.
And then third.
Inverse Fourier.
Yes. See here. This is not needed. So omega T, and then writing this function inverse Fourier x2 is this function and T time domain signal, right?
Yes.
Now you were finding the in the previous slides you had all the continuous functions. For example, unit step, triangle, all these were the continuous signals, right? Now I have my signal in discrete domain. Some samples, number of samples I have. Okay. So I want to convert these number of samples which are in time domain. I want to convert them in frequency domain. So I will take FFT for that. So here in FFT, I don't have to define symbols. I don't have to do anything. I will just plot the frequency spectrum of the discrete time domain signal. Okay. So for that, the command is FFT. And then for that, I need the signal and then number of points, number of sample points. Okay. So FFT xn, x is the signal, n is the number of samples. Okay. This will return me the discrete Fourier transform of my continuous time domain discrete signals. Okay. Then I will normalize. This is the normalizing factor. Okay. This will normalize my FFT and my endpoint DFT. It will be normalized by K. It can be any constant. Then FFT shift. What this will do? For example, you have some number of points 100. You take FFT. Then this FFT shift will distribute your function exactly at 0. So it means if you have 100 points, this will be minus 50. This will be 50. And then you will have frequency spectrum like this. It will take all the 0 frequency components across 0. Okay? Do you understand this? So now there is another command. C is equal to 3 plus 4i, right? So this is a complex number. Okay? If I want to find the absolute value of this number, how I will just write this as command in MATLAB and then it will give me the absolute number. So in maths, how can you find the absolute number? 3 square plus 4 square.
4 square.
Yes. This is 9 plus 16. This is equal to 25. And square root of 25 is 5. This is here, this answer. So MATLAB does all these steps itself and gave me the answer. Okay? Right?
Yes.
So now there is an example. Let sine of omega naught of t is the signal and f naught is 5 hertz, right? And then my time scale is 0 to 3. Okay? And increment is 0.01. Okay? Find the sampling frequency. So can anyone tell me what is sampling frequency? What is sampling frequency? In the previous class also, I told you the sampling frequency is the number of cycles per second. Okay. So here in this case, if I divide the increment, so this increment means that one cycle is completing in this 0.01 interval. Okay. So if I divide 0.01, it will give me sampling frequency. Okay. So let's see. So the first step is defining the scale, defining the fundamental frequency, writing the signals. Now this command will define the number of samples. So number of samples will be exactly by up till the length of my signal, this M. And then where this signal is going? Up to T. And T is here. You got it? You got the point?
Yes.
Yes. Then sampling frequency Fs is equal to 1 divided by 0.01. I explained you in the previous that one sample is completing in 0.01. So number of cycles per second 0.01. So this will give me 100 samples. Now define the frequency. So F is equal to line space. What line space does? It will distribute. For example, you have this colon operator. If you don't put it here, 0 to 50, what it will do? It will make an increment of 1. But line space will exactly distribute. For example, this is 100 by 2 minus 50, 50, and out of 100 samples, it will equally distribute the scale. Okay? Right?
Yes.
Then FFT, then I will calculate the FFT of M, my original signal, number of samples, and then normalize with total number of samples. Then FFT shift, I explained to you in the previous example, in the previous slide also. This FFT shift will exactly locate all the zero frequency signals across 0, and then it will divide the scale exactly in half points, minus 50 to plus 50. And then absolute value, it will take the absolute positive. All the values will be positive. Okay, and without the complex number, all the values will be positive integers. Okay, so either you write this 3 commands or you write this 1 command. This is same. This take FFT of this signal and then take FFT shift and then absolute value. These 3 steps are same like this. These 3 are same. Okay, then the last step, you will plot this signal. This is time domain signal, and then here frequency domain signal you will plot. Understand?
Yes.
Okay. So this is my frequency domain signal, and then this is my frequency spectrum. You can see that this is exactly distributed across minus 50 to 50, and then here you can see because of this FFT shift, exactly distributed across 0. Right? So you got the idea of all the commands?
Yes.
Yes. So quickly I will go through. I will upload these slides also. I want to go through your assessment. The assessment is the same almost.
Assessment is uploaded.
It's lab submission report.
Okay.
You will submit PDF this time, okay? All of you.
Yes.
Just
I
go.
already submit the second one also PDF.
Okay. So when this open, I tell you how. So it's easy to convert it to PDF. Just go here, save as, and then from here you have to select PDF, and then this will save PDF. Now these are your assessment questions. So you have this signal. You have to find its Fourier transform. You know, very simple. You will just define as symbolic variables, write the function, and then put the command Fourier. Then inverse Fourier, same method, same, and then writing the signal and then writing the inverse Fourier. Now here this third question is exactly similar to my last example, which is in the slides. Okay. So you have signal f naught is equal to 8. So scale is from 0 to 2. Increment is 0.009. So what is sampling frequency? 1 divided by 0.009. Okay. Then so find the Fourier transform. So what you have to do, you have to follow all the steps. You have to write line space, and then you have to find FFT of the signal with respect to the number of samples, and then you have to take FFT shift, and then you have to take the absolute value, and then you will be able to, then at the end, C of T, C of F. C of T means the time domain signal, and C of F means the frequency domain signal. So same like I explained in the previous slide. So this will be the same. Okay.
Yes.
So any confusion or any question, please ask. And then all of you. Yes. Yes, Zainab.
To our Mahmoud, how I can install the sample again?
وقت اللي تسوين له داونلود من الماتلاب الموقع،
يعني ارد اسوي له داونلود؟
اي مسحين من الكمبيوتر كله وسوي له داونلود مره ثانيه.
زين.
وحجم الملف راح يكون كبير، تقريبا 27 او 26 جيج، فمو شويه.
تمام.
المهم لما تبطلين تسوي له داونلود راح يبين لك البرامج اللي هو المفروض ينزلها.
You can ask Mahmoud after the class.
Okay.
So please tell me if it is clear to all of you. Is it clear? Okay.
Confusing this lab.
Why? What is it? This is very simple lab. That's why I didn't took too much time. Just simple. You have to define the variables because your answer, in your answer you have the variables. Then you define the define your signal, and then finally plot the Fourier. So finally calculate the Fourier. With there are the built-in commands. So what is the confusion? Is it clear to all other people?
It's clear. Yes. We have to practice.
Yes,
command.
you have to practice the commands. You have to memorize the command. These one.
Yeah.
Fourier and inverse Fourier, and then for the last example, just you have to take care of writing these commands so that you get a spectrum which is equally distributed. So there is nothing very difficult here. Okay.
Yes.
All right. So this is all done for today class. So if please upload your file in PDF, and I think I already posted the submission link, but I will post it. If not, I will post it now, and it will not take too much time for you. Maybe 15 minutes work only. Okay.
Okay. Thank you. Thank you so much.
Okay. Thank you. Bye bye. Take care. Have a nice weekend.
You too. Bye bye.
You must